you remind me now. Okay, so we have example number 4. We have an AC air conditioning unit, 39 amps, 240 three-phase. We need to size the conductor, the branch circuit for it, and also we need to size number 2, the overcome protection device. And as always, we need to size the equipment grounded conductor, which is number 3, equipment ground conductor. The reason why I put the equipment ground conductor out, guys, just because the calculation for it is different. Otherwise, it would be represented by the one-line diagram that you see, that number 1. I throw it out there just because it's different. If it's a 3-phase machine, the assumption is always 3-phase, no neutral, unless they tell you otherwise. All right, let's go ahead and do it. Number 1. Now, for number 1, we need a branch circuit conductors. To do the branch circuit conductors, guys, the article that talks about HVAC equipment is Article 440. Article 440, and this is not, we're not going to study it in details, but I'm going to tell you the ampacity for 440 overcome protection device and continuous load branch circuit conductors, 440.32 from 440.32 article. If you go to 440.32, it will tell you 440.32. It will tell you to size the conductors. You have a 1.25 times the full load current, continuous load. That's what it tells you. It's a continuous load. Okay, so I have a 1.25 multiplied by AC, guys. They have a nameplate current. You use the nameplate current for ACs because they don't size them. They size them in tons. They don't size them in motors. We use the AC for the unit. So what's the AC full load current for this unit? 39 amps. Okay, who's going to do the math for Chad? This equal 48. Even 48 amps. 0.75. That'll make it 49. Always approximate 49 amps. Okay. Then you take the 49 amps always to 310.16 under. You're going to take it to 310.16 under. For HVAC equipment, we don't know it's a motor. By the way, when we did the motor, did we go under 60-degree column or 75-degree column? When we did it for motors? 60? It's okay, but we could have gone under 75-degree column for motors because of the exception. I'll do one more.
I got a question.
Yes, sir.
440.32 is a single motor compressor. So that's 3-phase. I mean, do we have to take in consideration that might be a Y start delta run?
No,
Okay.
at this time.
Okay.
No. We're not going to get into the start. Yeah. 49 compact. This is across the line start. So if you take this one, 49 guys, if I don't know, there's nothing about them, so we're going to default to 60 degree column. What would that give me? Number 6. Number 6. How many? 3 conductors, number 6. Okay, that's the default. If they tell you guys that the lugs are rated, if you know that the lugs are rated for 75 degree, you can go to 75 degree column even though the amps are less than 49. You can. But if you don't know, as our situation, default to 100 or less, 60. Make it easy. Number 2. Overcurrent protection device. The overcurrent protection device, guys, for these come from 440.22, 440.22a. If you do yourself a favor and Chad, and you go to 440.22a, it's an article, not a table, it will tell you you can use 175% multiplied by the nameplate, or if it doesn't start, you use 225%. 225%. Okay, I'm going to assume it's not going to start. I use the worst scenario. So then it becomes 2.25 multiplied. What's the full load current for this piece of equipment? 39 amps. What would that give me? I know some of you will say, Chad, where the heck did you get that piece of equipment? Where did you get the 2.25? This 2.25, guys, it came from right in here. If you go to this article, it tells you you can either multiply by 175 and do your calculation. If 175 does not hit you there, meaning every time you size based on it, push the button to start the machine, circuit breaker will trip. Then you can go to 225, 225% extra multiplied by the full load current. What would you get here?
87.
How much?
87. 87%.
Okay. 88. What? 88 or 89?
88. I'm sorry.
88. 88 amps. 88 amps. Okay. Any question up to that? So 88 amps. Now, obviously, you still have the two options: either go drink at the bar and cry because there's no 88 circuit breaker or fuse. You can custom design yourself, or what does it say go up? For motors, it says go up. This one, if you read guys article 440.22, shall not exceed. That doesn't say any, there's no exception to go up. If it says shall not exceed, can you go up? No. So if you can't go up and you don't want to go to the bar and cry, what's your other, and you don't want to custom your design, custom yourself a fuse, what's your only option? To go down. So that's where we go down here. If it's, see that arrow, guys? Mr. Erbab, you see that big arrow that looks like, this means go down if it's not a standard. Okay? So, piece of cake now. Let's go take the 88 amps. Where do we take them to check them? 240.6, and that will give me what? 9, we can't go 90, as mistake number one. Where do you go? 80 amps. Because you have to go down. Why do you have to go down? Why do you have to go down? Why do you have to go down? Because you can't stay where you are and you can't go up. And you don't want to sit and cry. So you have to go down. Yes, sir.
I'm not making you repeat yourself.
No.
Can't go up. Sorry.
Not read the language. It says not to exceed.
And where?
440.
Not to exceed. Oh, right.
Not to exceed.
Okay.
That's a
90 is
440?
on.
You can't go. You exceeded, right? 90
Right.
is exceeding 88.
Right.
You can't exceed. But I see your point. Why can't I go up, Chad? It's not to exceed. For the motor, Spencer, it says the same thing, except there's an exception. It says if one of the exceptions underneath the table of the motors, it says if you did not hit the standard, hey, no problem, go up. That's why we go up in the motors. That's the code, guys. Sometimes they put an end there. For this, just remember, for the HVAC equipment, no exceptions. You just go down.
And that's 440.
That's 440.
22.
440, 22.8.
Okay.
Right? 440, overcomputation by 440, 22.8. Okay, now, back again to number 3. Equipment grounding conductor. The same calculation. What's an 80 amp? Take an 80 amp to where? To table 250.122. That will get you a healthy.
Maybe number 8.
Healthy number 8. Number 8. How many? 1. Okay, here's my question for you guys. Right, number 8. Did you guys get some number 8? Number 8. Anybody got number 8? Okay. Now the same rule applies. If this calculation was higher than number 6, is number 8 higher than number 6? Wire gauge, not number wise.
Yes.
Wire gauge. Wire gauge, is number 8 higher than number 6? Higher? Number 6? The thicker?
Oh, no.
No. Number 8 is smaller conductor than number 6. So we're okay. Had this number end up being 4, then you can stay where you are if you want to, but you can go and match it to the phase conductors. Okay, can you guys use yourself? And I want to say, I write a little note here. Equipment grounding conductor equal or less than branch circuit. Can you guys write yourself a note here? It doesn't have to be higher than the branch circuit conductor. And the reason why they do this, guys, because you could end up higher. So it doesn't have to be higher.
What is an AC if not a motor bill? Why can't you go up?
Good question. ACs is a special type of motor that has compressor with it.
Man,
It functioned, yeah, it functions differently. That's why because it functions differently, they took it and they treat it differently and they put it in one article because it functions differently. It has a compressor. HVAC equipment. How can I identify an HVAC equipment? Anything that has a compressor, refrigerating side compressor is a really key word for it. Any motor that drives a compressor, that makes it an HVAC type, refrigeration and heating and cooling, cooling in particular. So the word is compressor. Does it have a compressor with it to compress the refrigerant to get you cooling system? That's how we get cooling.
does the, them geo ones have,
Geo ones.
like where they,
Geothermal.
geothermal,
Geothermal.
do they have a compressor in them too?
I don't know. Honestly, I'm not familiar with it. Anybody have seen them? If they have a geothermal, I thought they take it and they circulate maybe to get you cool.
Yeah,
And
and
heat?
probably they do the same thing with.
They could. They
taking
might
that
have an
heat off the
auxiliary.
air.
Yeah, I thought they take the heat from Mother
Oil on the
Earth.
ground.
Coil, the coil. I don't know if they have refrigerant with them.
I don't think so. We had one installed at our house.
My brother-in-law.
I don't think it's a refrigerant. I don't think they circulate. They just take the water, they get the heat or the cool and dump it into the house, depending on what they are.
Oh, yeah.
Because the temperature, the earth temperature stays constant. So they grab the earth, not earth temperature, yeah, the earth temperature stays constant down. So they grab that and modify it to your house, the heat or cool. Okay, any questions about this? Cool. All right, let's move on to. There you go. Did you fill? Did we cut another tree? Okay, let's. There's one little thing, guys. I wanna emphasize. Example number. Example number. Where are we? 5. 5. Here's a big piece of equipment. This piece of equipment, though, is um 800. Let's just use. I don't want the 800. Let's use this one. A 300. Chad, make up your mind, would you? Let's use 730 amps. I decided. I bought a piece of equipment. 730 amps.
You sure? I don't have any razor.
No, that's it. Make up your mind, Chad. And I need to size number 1. I need to size number 2, and guess what? I need also number 3. Can you guys see that we're following the same rhythm? Kinda. We're in rhythm. We don't want to switch gears, otherwise we just keep going the same thing over and over in different angles. 730 amp piece of equipment. And we need to size for this piece of equipment. Okay, it's continuous, by the way. Continuous. The voltage in this, pick and choose. Anything could be 480, 208. Really doesn't matter. Any voltage system. I don't care. If I get the amps, I don't care. Because if I get the amps, I can size the conductors and overconduction device. I really don't care about the voltage as long as 600 or less. Not higher voltage than 600. All right, let's do it. Number 1. DJ, am I going too fast?
No.
Okay, good. You're my gauge.
Okay,
My parameter.
thanks.
Okay, number 1. What did we say? Number 1. We need conductors. Branch, the fancy name. Branch, circuit, conductors. Oh, by the way, when we size a conductor, if I ask you to size the conduit for the conductors, would it be hard? We just did that. If it's 3 conductors per odd, can you find a conduit? What conduit, Chad? EMT? What insulation, Chad? It's inside THHN. You can size the conduits right away. So it's a continuous. So 1.25 times 730 amps. What would that give you, my friends? 2 gentlemen or a gentleman and a lady. How much?
913.
Go up if it's 0.5. 913 amps. Great. 913 amps. 913 amps. Okay. can you do me a favor? Just leave a couple of lines empty here. I'm going to finish this one after I do the overcomplication device for one reason. Just keep a couple of lines empty here. I'm going to jump down. I'll finish it in a second. I'm just going to down to the overcurrent protection device. Jump to the overcomplication device. Just keep one line between them. Everybody got that one? Just keep one line. I'm going to get back to it. The same thing. It's continuous load. What do you do for an overcomplication device? You take 1.25, multiply it by 730. Well, that will give you 913 amps. 913 amps. All right? 913 amps. 913 amps. See the two together now? I want you guys to look at both of them. Here's what the code says, and this is an article. Let me write the article. 240.4 B and C. B and C. So this is from 240. What did you say? 240.4
B and C.
240.4 B and C. If you guys look at 240.4 B and C, it says, as you size your overcam protection device for a conductor, you can always, conductor, non-motor, nothing. If you size the overcam protection device for a conductor, continuous, non-continuous, you can go up if you don't hit the standard until you hit the ceiling of what's the ceiling? 800. When you hit the ceiling 800, then you have two options. Either you go down on the conductor, or in the overcam protection device, you lower the overcam protection device, or you match it to the match the conductor to the overcam protection device. Okay, so here's my question for you. Am I higher? So when you reach this point, here, what I want you guys to write, I want you to write 913 amps is more than 800 amp. More than 800 amp, right? More than 800 amp. Write this one. 913 amp is more than 800 amp, right? Then, write yourself, then match conductors to overcurrent protection device. That's what technically we do. If your calculation on this situation, switch gear, that's a switch gear. If you end up with a number higher than 800 amp, stop. Match the conductor to the overcurrent protection device. That's the best scenario. Okay? That's why I said I want to stop here. No, since I want to match it, then what do I need to do? I need to go size it first. I need to go size it. So let's take 913 amps. Take this one to 240.6. Can you guys find me now overcam protection device that can handle this? 1,000. Anybody found 1,000? There's no 950 unless you custom design it. It's 1,000. So I have 1,000 amp. My overcurrent protection device for this piece of equipment is 1,000 amp. Okay? 1,000 amp. Then now I know. Now I'm going to go match the conductor to the 1,000, right? So I'm going to go back to my conductors. Can I grab this one, guys, and put it right in here? Call it 1, continue. So I'm going to take the 1,000 amp. Since I can't carry a conductor with 1,000, I single-handedly, Chad Curdy, decided to parallel 3 runs. You can do 2. I'm going to put 3 runs. Why did I divide by 3? Why did I divide the 1,000 by? Why did I pick the 1,000? Because of more than 800. Why did I divide by 3? Because I single-handedly decided to go more than 3, and 3 would give me 353 amps, guys, and that will get me around the 450 or 500 kcm, which is a good scenario. Okay, so that will get you 333 amps. Anybody disagree with that? If you divide 1,000 by 3, get you 333 forever. We learned this when we were in grade school, and I hated that. Why? Because it doesn't stop going 333. It kind of bothers you. Gotta have an end. Okay, then you take this one to, where do we go? to size conductors, not to Bloomington. 310,
Richfield.
that's 16 for Richfield. Under which column? And why? 75.
75.
And why? Because we're 100, we're more than 100. So 75, no question here, we're more than 100, huh? 75, what would that give you guys? How much?
400.
400, okay, 400. How many conductors KCM? How many conductors of this type do I need? It's a three-phase system. Did they say a three-phase system? Oh, let's make a three-phase system here. Three-phase system, KCM. I doubt that you will find a load that this single phase. You would though if you find the. I was surprised to look at some of these DeWalt guys. They have a switchgear single phase for 2,000 amps single phase. I guess if you live in an area where there's no three-phase system service, the utility has to give you, and you need a lot of power. What they're going to do? They're going to give you a 2,000 amp single phase. That's not good for the transmission lines. They like, if it goes higher amps, they want you to take three-phase so you balance the system. Okay, how many did we say? 3 conductors. This is poor man or woman's job to write it. 3 conductors, 400 kcm. What am I missing?
EKV or ET.
We'll do the ground in a second. I'm missing. Look, did I parallel? 3 sets. You have to tell them that 3 sets. 3 sets. So I need to write 3 sets. Now I'm good. Now I'm good. Because if you just put 3 conductors, 400 kcm each, are you kidding me? What happened to the 1,000 when we need to carry 1,000 amp? You need to say 3 sets. What does 3 sets? Means the 3 conduits like this with 3 conductors each carrying the 1,000 amp. 3 conduits. Each conduit will carry 3 conductors. Okay. We didn't say anything about the neutral because we're assuming a machine is just 3-phase, no neutral. All right. Any question guys about this? So match the conductors to the overcome protection device. That's option 1. If you don't like that, option 2. I started with option 1, guys, because that's what I do in my projects. I go up and match it. I'm an engineer. I don't care about the cover, right? Throw cover. Option number 2 is you take the overcome protection device. Instead of going up, look at that. I went up. What if I go down? 913. What's the next one down? Next overcome protection device down. 800. There's no 900. Okay, 800. Now, I don't want you to write this down, but this is the scenario. Instead of going up here to 1,000, go down to 800. Now I have an 800, right? 800. And I size my conductors, my overcome protection device is 800. I decided to choose it down, 800. Now look at my conductor size, and then I'm going to size my conductors for what? 913. My conductor's amp is 913, and my overcome protection device is 800. Am I okay? Am I? You always want your conductors either to match the overcome protection device, or the overcome protection device can be slightly bigger. If it's the overcome protection device is lower, it's okay. You're safe, right? Like for example, here's an example. I have 15 amp circuit breaker. Can I put number 12 and 15 amp circuit breaker? No problem. Bring it on. That's the same scenario. I have number 12 conductor tied to number 15 circuit breaker. Is it okay? Yes. So I have an 800 amp circuit breaker tied to a 900 amp conductor. That's okay. So that's another scenario. You size the conductors exactly like based on the 913 amps. That would make it a cheap design. 913 amps, okay, exactly like we did. But then overcome protection device go down. Now here's my question for you guys. If I went down on the overcome protection device, and my amps are still higher than 913, right? Then you have to match the overcome protection device. See, if I went down on the 913 here, and I end up with 950, I don't know how we're gonna do that, but if I end up here with 950, and this is 913, can I do it? No. This amp has to be bigger than this amp, equal or bigger than this amp when you size the conductors. But this is how I do it, guys. Go up in the overcome protection device and then size your conductors to match the overcome protection device. We're good. My conductor matches the overcome protection device. Good to go. Any questions? So I want you guys to highlight the 4 240, not B and C, because they're very, very important. The 800 amp ceiling, they call it the 800 amp ceiling. 800 amp ceiling. Any question about that?
In order to come to, when you say you have three amps and you go to take 310 that 16
Yep.
over 7 sites, reduce the TV.
Yep.
167.
Yep.
So here I get 360 and you say 350, right? 350. And then you go to that column and you have 310. In that case, do you decide it? Am I correct there? Get 310 over here.
Your amps are 333.
Yes.
So you need under 75 column, you need to find an amp 333 amps or more. You can't go to 330, for example, because your amps are 333.
So it's 350. I go to
Yep, 350.
And then in that column I have 310.
No, you have 335.
There's a 335 there, column.
Oh, I see. Okay. So
Okay.
you mean that you went to 400?
Yes,
I see. Okay. Not 350.
not 350. Because the next amps is 333, the next one is 335, right? If you cross 335 amps,
335.
take it all the way to the first column, which is the KCM, that should give you 400, right?
Right.
Mr. Rabab?
I have 350 here.
You're in the 90-degree column. Yeah, but
You guys are taking care of that. Okay. Let me size the equipment grounding conductor, guys. Number 3. Don't forget the equipment grounding conductor, or this piece of equipment. The equipment grounding conductor. The equipment grounding conductor, guys. How do we size the equipment grounding conductor? Based on the over current protection device. Again, here's my 1000 amp. Take the 1000 amp to table 250.122. That will get you a healthy number. 2 watt. How many of them? One conductor, 2 watt. One conductor, 2 watt. One conductor, 2 watt. Now, what you guys, right? Everybody, guys? One conductor, 2 watt. I want you to get yourself, when we parallel these guys, just FYI, I wish we had more room and sometimes to draw. I'm going to draw them here. My 3 parallels. Here's my, oh, I need a black. Here's my conduit number 1. Here's my conduit number 2. Here's my conduit number 3. 3 conduits, right? Anybody has an issue with that? This conduit is going to be conductor, 1 conductor, 2 conductors, 3 conductors. What are these? Phase A, B, and C. And the same thing, this one, guys, will have 1 conductor, 2 conductor, where did we, 2 conductor, and the third one would be, and this one will have the same, just trying to color code it. Okay, can you guys see that each one of them has 3 conductors, plus the neutral, of course, plus the neutral. Here's my neutral, oops, no, I want the neutral green. Here's my neutral, here's my neutral, and here's my neutral. Can you guys see that? These are the 3 conduits that I ran to carry this 1000 amp. Another neutral, the ground, the equipment grounding conductor. I'm sorry, the equipment grounding conductor, no neutral, equipment grounding conductor. When you parallel, the code says you have, see that 2 aught? You have to run a 2 aught with every single run, every single conduit. Because there's 3 runs here and I came up with 2 aught. Should I put the 2 aught in conduit 1, conduit 2 or conduit 3. The code says if you parallel, then you have to put the equipment grounding conductor with every paralleled run, with every conduit. So there will be a 2-aught here, a 2-aught here, and a 2-aught here. And if I was 4 runs, Spencer, there will be another 2-aught in the 4th run. Ryan.
So you need to put, oh, I suppose you have 3 sets.
I have 3 sets.
3 sets at the top.
Yep. 3 sets, then 1 conductor 2-aught with every set. Yes, sir.
So you can't run them in the same conduit.
You can. 2 things.
Why wouldn't we do that?
Oh, good. How many are there? 400 kcm. Try to find
I'm
me.
just asking.
Trying to. That's a good point. Here's the physics. It's really physics. The largest conduit that you can get EMT, which is the most common, is 4 inches.
Okay.
You cannot. You have to check. Go check if you can see 9 conductors. 9 conductors, 400 kcm plus a 1 conductor 2-aught. If you put them all in one conduit, then yes, 1 conductor. If you put them in separate conduit, and that's number 1. Number 2, it's a nightmare to pull 9 conductors. It's just physics. Can I custom design a conduit for myself? Yes, absolutely. If they are in a cable tray, they use cable trays. Yes. Can I put them all in a cable tray and line them next to each other, and I run with them 1 conductor 2-aught? Bring it on, no problem. But because we can't fit them, physics. Ryan, any question, my friend?
No.
Did they keep calling you Ryan or Ryan?
Ryan.
Ryan.
Everyone has problems.
That's a Brian with the Brian Ryan, huh? Ryan.
You
You have to roll your R. Sorry, I'm sorry.
can only get 7.
By 7, now there's 2 more. Yep. But if it's rigid, you might be able to fit them. But Brad, don't even go there. It's not a good idea. Because
let's
of
just say for
nightmare.
the sake of illustration that we could run them all on the same
Yes, you can.
conduit.
Then you can.
If we could, we only need to put
Yes.
1.
Yes,
down? Okay.
absolutely, absolutely. But it's a nightmare installation.
Okay.
Okay, any question, guys? That's when the electricians start making fun of the engineers. We're gonna avoid that,
That's okay.
you know.
I'll just show up my paycheck.
It's less than theirs.
And you can mix and
Brad,
match.
you don't want to do that.
I get stuff theirs. 'Cause I didn't-
I'm sorry. say that
I
again.
say you could kind of mix and match too, right?
Mix and
Let's say
match.
you have
Yeah, but 2 of them in one and the third in the other.
besides 400
Yeah.
ACM.
The question is, can I put these 2 in one conduit and that one in a third one? Yes. Then you have to run 1 2-aught with these 2 sets and 1 with the other set. Every time you have a
Well, what if
conduit,
you had a mixed bag, but you get there amperage wise, is that all right?
mixed bag, but
Can't give you an example.
Ah,
but let's say you
no,
have
I can give you an example.
multiple 4-aughts.
With parallel, here's the question, because that comes all the time. Can I take phase A? Can I take phase A and parallel for phase A 5 runs of 4-aughts? Take phase B and parallel 3 runs of 450. Phase C 2 runs of 750. Can I do that? Yes, you can. Nightmare to work with. People will laugh at you, but yes, you can. Technically, you can. No question asked. Yep. Because when you parallel, guys, you're paralleling phase A conductors. Phase A conductors can be aluminum, and phase B and B conductor could be copper. They could be phase A conductors and phase B conductor has nothing to do with each other. They're not paralleled with each other. See that when parallel means tie at the end, you only tie at the end the conductors of the same phase. These are the parallel conductor. These must be the same. If you're using 4-aught, 4-aught. If you're using copper, copper. If you're using, you know what I mean? But phase B could be completely different size conductor, completely different conduit, completely different insulation, completely different copper or aluminum type of conductor. When we parallel conductor, guys, everybody knows, when we parallel them, the way I did them here, the conduit has, all conduits of these has to be the same, EMT or rigid or PVC. All the conductors must be the same size. The insulation must be the same. Termination must be terminated the same logs. And what else did we forget? Length, most important. You have to cut them, measure them, and cut them the same length. Because if you don't do that, if there is a difference of say 20% length between this one and this one, Guess what? This one, instead of carrying 33 amps, it will be carrying 450 amps, and this one will be carrying 150 amps. Who cares, Chad? Now you burn this one. They call it hogging the load. One set will hog the load, and the other set will sit there just because it's long. Remember, the current goes, guys, through the shortest impedance. The shortest impedance. The shorter or the smallest impedance. The shortest run will have the smallest impedance. Okay, so it takes the most of the current. The longest run will have the highest impedance, so will take less current. Long story short, you need all these runs to be the same length, same insulation, same type of conductor, copper aluminum, same conduit type, same termination. So you can't parallel. The way I'm showing it right now, you can't put this rigid and this is EMT. Does that make sense, guys? Should I move to the second and almost the last question that we have? We have 15 minutes. You guys are paid for 15 minutes. I can't just let you off the hook here. After 15 minutes, buddy. Your tummy can handle that.
Of course you can, sir.
Just for you, friend Chad. Okay, let's go. Which one we are? Holly, this is number 6. Number 6. Okay. Example number 6. We got an example about a lot of other stuff. Neutral, we get that one. Okay. I have a 400 amp panel and 800 amp panel, 480 volt. Really, you don't need to know the voltage in it. And I need to size the following. I need to size number 1, number 2, number 3, number 4. I added number 4 this time. Okay, I have a panel right there, like this one, a panel, and I need to size for this panel, guys, an 800 amp panel, 480, for all practical reasons, could be any panel, 208, 480, any panel, really doesn't matter. Single phase, let's make it 3 phase because it's a big boy, 3 phase. And I need to size the conductor for the panel. Already, the panel is already sized, and we know the load, we calculated the load, we decided the panel that we need is an 800 amp panel. Set. We took into consideration, I want you guys to wake up. Somebody will say, Chad, is this continuous load, non-continuous load? When we came up with the 800 amp, we took into consideration the continuous, we added the non-continuous load with the continuous load, and we kept adding them to land until we landed at an 800 amp panel. Okay, everything taken into consideration. It's a panel, we size it. You guys, I'm going to be walking you through how to size it. We took the continuous load plus the non-continuous load plus the motor plus the HVAC, everything all together, came up with, say 750, and I went up to an 800 amp panel, and I need to go and size things for it. Okay, 800 amp panel. All right, for an 800 amp panel, I need to size the following. Number 1, conductor. Conductor size. I need branch. I don't want to say a branch circuitry, it's a feeder really. I want to say feeder. Feeder conductors for phases. For the phases. I'm sizing the feeder conductor for the phases. First, not the neutral. The blue one is a neutral. Okay. I need to parallel. I have an 800 amp. Here's my 800 amp load. Divided by 2. Why did I divide it by 2? Why did I divide it by 2? 800 amp. Parallel amp. So that will give me what? 400 amp. And then take this one to 310.16 under 75-degree column. I have 2 sets of 3 conductors. Each one of them is 600. I'm coming to this in a second. Some of you might say, well, Chad, I've seen it with 500. Okay? 600. Anybody has a problem with that? See my lawyer. Okay, number one. Since I'm dealing with conductors, guys, I'm going to go ahead and size the neutral. So I'm going to jump to number 4, just to get the conductors out of the way. Number 4, feeder neutral. For feeder neutral, okay, feeder neutral. I have an 800 amp. If you take the feeder neutral, remember the calculation that allow you to derate the neutral? That's 220 dot neutral, 220.61 permitted reduction. 220.61b. Go to 220.61b. If you go to 220.61b, it tells you anything higher than 800 amp, chop it by 70%. Okay, Chad, here's a 200 amp plus anything higher than 200. What's higher than 200 amp? Here's meaning 800 amp minus 200. Cut this one by 0.7. Everybody knows how to read this? If you go to 220.61 says the first 200 amp, leave them alone. I left them alone. Anything higher than 200 amp, what does anything higher than 200 amp? You take your amps, subtract your amps from a 200 amp, that's a higher than 100 amp, cut them by 70%. Everybody knows how to read this, guys? 200 plus 800 minus 200 times 0.7. This reminds me of the days of arithmetics. Who's going to do the math for me? So 200, how much? 620. Anybody? I need a lot of gentlemen to agree with 620 amps. I need another gentleman or a lady. 620. Okay. 2 gentlemen will never agree on something wrong. That's a rule.
Yeah.
Okay, 620. Everybody knows what I did? I took the amps, cut them by 70%, anything higher than 200. Why did I do that, Spencer? 220 to 61.
Leave the first 200 alone.
Yep.
Take the remaining.
Yep.
600 minus 0.7.
Oh,
Which is
I see.
420.
So the remaining for
Okay.
these, this becomes 600,
Yeah.
right? Everybody knows when you subtract from 600, cut it by, multiply by 0.7. Everybody knows why 620? Now, moment of truth. Since I parallel the phases, what do I need to do with the neutrals? I need to parallel the neutrals. I can't carry the neutral with one conductor. I can, I guess, but then I have to run a huge conductor with each one of these. So I need to take that 620 divided by 2. What would that give you guys? 310 amps, right? Then you take the 310 amps. We take this one to table 310.16. So if you take it to 310.16, table 310.16, what do you get? Do we get 350? Right? 350? I need another gentleman other than me to say 350. 350? Okay. I didn't see it, I just guessed it. 350, how many sets? 2 sets of 1 conductor, 350 kcm. Okay? Look at the phases. What was the phases? 600. The neutral, 350. Did we do something wrong?
Where do you get 620 from? Because you're taking it, because you can't derate the first 200.
Yes.
So then you have 600 left over, you're taking times 70%.
Yeah.
420.
It's 420, isn't it?
Plus 200.
Oh, you're adding, that's right.
Yeah, you add it back again.
Okay.
Is this right here?
Yeah.
Okay. Now, your options, either you put the neutrals in one conduit, PVC only, phase A in one conduit, phase B in one conduit, phase C in another conduit, not commonly used in the industry, and parallel them. Or you put two conduits, and inside this conduit, most likely you're going to be paralleling them, guys, this way. That's the most common way of paralleling these boys. As is 1, 2, 3, and the other one is going to have 1, a 2, and a 3, and I'm going to have a neutral with ground with each one of them, and I don't have a third color for the neutral. So which color did we use? Let's use another blue. Just identify this blue as N neutral. Identify this blue as N neutral. How many conductors do I have in each one of these? 4 or 5 conductors. 3 phases, 1 neutral, different sizes, the phases in the neutral, and a ground that I'm going to be sizing in a second. And then we're done, then you can go eat. Just for the record, DJ. Any question guys so far? Okay, the last thing, finally, we're going to do, we need to do the overcam. The overcam protection device, guys, is very easy. Overcam protection device is very easy. So I'm going to go number 2, overcurrent protection device. You're going to take the 800 amp, take it to where? 240.6, take it to 240.6. Do I have an 800 amp overcam protection device? I think so. So that will be an 800 amp. Here's my question for you. If you have a panel, say I picked a panel, the size of the panels, guys, does not match the size of overcam protection device. Say if I have a size of a panel, 900. See, if I picked a 900 amp, assume there's a 900 amp panel. I have a 900 amp panel, and I need to size the overcam protection device for it. And my option is either I go to 800 or 1000. What would you do? It's a panel. 800. You can't put an overcam protection device on a panel that's higher than what the panel is rated for. If your panel is 900, either you put a 900 on it, or you go to 800, but you cannot put a 1000 amp circuit breaker to protect an 800 amp panel. Panels, which is that one is a panel. Okay, so the last thing, which is going to do, what was it? No, last thing is number 3. Number 3 is equipment grounding conductor. Equipment grounding conductor is sized based on the overcam protection device. I know it's an 800 amp because I've just sized it. You're going to take it to table 250.122, and that will get you a healthy DJ.
Healthy amount.
Yeah, but we need the amount. Why not? Why not? How many? 2. Why 2? Because I'm doing 2 runs. Why 2? How many of them do I need? It's a 1 aught, right? 1 aught. It's 1 aught. But how many of them do I need? How many of the 1 aughts do I need, guys, and why? I need 2 of them. And 1 aught AWG. Why 2 1 aughts? I need a lady or a gentleman to answer. Why 2? We're running 2 runs. We're paralleling 2 runs. So 1 with everyone, the same size. Now, had I grouped them all in one big conduit, then I need one conductor. What's that? What did you say?
Said hi, Grandma Chad.
Hi, Grandma Chad. Any question, guys? Any question? This is what distinguishes you from being a drafter. That's it. I mean, it really is. If you, some of you guys want to do the drafting and be okay with that for the rest of your life, and somebody will give you all the sizes here, draft this stuff for me, and you're happy with this, be it. If you want to go to the next level and be the designer, project manager, that's what the program is supposed to get you into, you know. You still need to draft though, don't misunderstand me. You still have to draft. Why it's shaking? Okay. Any question, guys? That's all I have for you today. Yes, sir. Yeah, let me just, can I close mine here?
What
Thanks.
would you label as new sizing conductors and overcurrent devices? What would you call this?
Sizing conductors and overcompression devices for loads.
Size